Good morning. Welcome to Rational Expressions lesson number 1. And we're going to talk about, this is on page 417 of your book. And while you're going there, I will just give you a kind of a update of what we're going to be doing. So we're going to be talking about, it says in this unit, we will study rational expressions and equations. We will determine non-permissible values of a rational expression and restrictions on the variable. So these non-permissible values are what we're going to study today. It says we will also determine equivalent forms of rational expression, and we will learn to add, subtract, multiply, and divide rational expressions where the numerator and denominator are monomials or binomials. In addition, we will learn how to solve problems involving rational equations. So that all seems probably overwhelming and you don't need to worry about it yet. We'll talk about it in a while. Okay, so now this says, I don't want this there. Oh, there. Rational expressions. In previous courses, we learned that the ratio or quotient of two integers is a rational number. So in other words, when we have a fraction, like 1/2, -5/3, 10/15, those are all examples of rational numbers. Now, the ratio or quotient of two polynomials is called a rational expression. So when we see this word polynomials, we're going to think about the things we've learned. Monomials, those are one term, or binomials, things that are when we have two terms, or trinomials. Those are all examples of very common polynomials. When we take two of those and we divide them, that's what the word quotient means, we get these what we call rational expressions, such as x plus 7 over x plus 8, and those examples here. Those are examples. So now, one of the keys to success, this is this guy, he's super important, in operating with rational expressions in this unit lies in the ability to, yes, you guessed it, factor, using the greatest common factor or a difference of squares. So when I said that was important to learn in the 20 level, I was really serious. So we're just going to go right on ahead, and I'm going to remind you how to write the following in fully factored form. So the first thing you do every single time is you try to pull out a common factor. So when I look at this 8x and minus 24, I take out an 8 and write down everything that I would need to get back to the original. Factoring is breaking into two pieces or more, but breaking into pieces things that multiply together to get back the original. All right, part B. When I look at part B, the things I see in common are a 2 and an x. And when I take it out, I would need to have 5x squared plus 1. Don't forget the plus 1. If I don't put the plus 1 there, I cannot get back the 2x in the original. All right, letter C. X squared minus 16. You go, oh yeah, two terms, minus sign between them, ding, ding, ding. I know what this means. This is the easy kind. This is the kind where we make two sets of brackets because there's nothing common. And we put down the square root of the first term and the square root of the last term, and one's a plus and one's a minus. That's called the difference implying to the negative sign of two squares. X squared and 16 are both squares. All right, letter D. Let me just change color for a second. All right, letter D, there's an x that's common. And when I pull out the x, I have to write down what I would need to get back the original. And when I do that, you think, oh, I'm done. And you go, no, you're not. Because here we have a difference of two squares. X squared and 1 are both squares. So I copy down the x. Don't forget to copy him down. And then I factor the difference of two squares. X, and a minus 1 and a plus 1. All right. So hopefully that's a reminder to you on how to factor. Just some basics. Pulling out a common factor and doing the difference of squares. And the last letter D was a combination of both. All right, turn the page. Now, when we talk about non-permissible values, we're going to be talking about things that make our expression, I guess you would say, undefined. So just for fun, they take an expression 6 over x and they say, well, what happens when x is 2? So when x is 2, we get 6 over x originally, but now that's a 2, so I make 3. Not a problem. But what happens when I put x is 0? Well, then I get 6 over 0, and all of a sudden, this is not defined. You cannot divide by 0. You will get an undefined error in your calculator. You cannot divide by 0. So I'll write a note here. You can't divide by 0. So important to remember that. Okay, so we're just going to look at 4 different expressions here, 6 over x, 10x over x plus 3, etc. We're going to look at them and we're just going to find out when is it defined and when is it not defined. So let's complete this table quickly. If the value of x here is 3, then the first spot here, we're going to have 6 over 3, which would give us a value of 2. It's not a problem. Let's go on down the page on this one. We'll go down the table. If x was 2, we would have 6 over 2, which is 3. Not a problem. What if it was 1? We'd have 6. Still, there's no issue. But all of a sudden when we get here, we are not defined. What if it's a negative 1? No problem. Same thing with the rest of these. There is no issue with dividing by those numbers. The only place it is not defined is here. Oh, mercy. Sorry. Is this spot right here. All right, let's go back to the top. What if it looks like this with a 10x and an x plus 3 in this column? Let's go through and do this column. Well, if x is 3, we're going to have 10 times 3 over 3 plus 3. Now I'm just replacing the x everywhere with this value of 3. So that becomes 30 over 6, which is 5. Not a problem. How about 2? Well, we would get 20 if I put x to be a 2 over 5, which would be 4. If x was a 1, I would have 10 over 4, which is 5 over 2. I'm like, when is this going to be 0? When is this going to be a problem? If I put 0 in, I'm going to get 0, 10 times 0 is 0, over 3. That's just 0. There is no problem with having 0 on the top of the fraction. The undefined part comes when it's on the bottom of a fraction. And as we go along, it's hard to see, but I'm going to get 10 times a negative 1, and then on the bottom I will have negative 1 plus 3. So that's going to be negative 10. And on the bottom, you owe $1, you have 3, which means you have $2, which ends up with a negative 5. All right, we can try this last one. If we put a negative 2 in for x, we get negative 20 over 1, which is negative 20. There's been no issues until this last column. If you put 10 and you times it by the x value, which is negative 3, and then you substitute the negative 3 into the bottom where the x is, all of a sudden you get negative 30 over 0, and this is not defined. So I hope you're starting to see that different expressions have different values of x that make them undefined. Let's just do a couple more here. Maybe I won't do them all. I'll do the ones that are important. So if I start on this next place here, it says the value of what's dumb.